Now let's go over to Surya. Surya? Yes, Surya, go ahead.
Are you able to see my screen?
Yes, click on the present. Yeah, perfect.
Okay, cool.
Yeah, go ahead.
So my research paper was on the an examination of post-translational modifications of alpha-synuclein and its effects on Parkinson's disease. And I'm Surya Kapu. I go to Corner Canyon High School in South Jordan, Utah. So just to give like an introduction, the topic that I was investigating is post-translational modifications of alpha-synuclein. So what post-translational modifications are is after a protein has been translated, that protein will be modified in a way that changes its properties. So if you add a certain chemical group, like let's say phosphate, that's going to change certain properties of that protein. And specifically in the case of alpha-synuclein, which it's a neuronal protein that's very associated with Parkinson's disease, like it's genetically linked and pathologically linked to it. So this research can kind of improve our understanding on the uh, pathology and pathogenesis of Parkinson's disease with respect to alpha-synuclein. So the specific research questions I set out to answer are, can post-translational modifications of alpha-synuclein change the properties of alpha-synuclein, and can the post-translational modifications of alpha-synuclein change the way Parkinson's develops in patients or even change the symptoms of Parkinson's disease? So, and I believe that these questions are important to answer because millions of people around the world are affected with Parkinson's disease, and very little is known about this disease. So understanding one of the potential factors that can contribute to PD is critical, and it could also lead to therapies in the future. And so my objectives of my research were to answer my research questions and examine different post-translational modifications of alpha-synuclein. For my literature review, I put some articles that helped me in my research, and just like an overview of the current research, there's a growing body of research that focuses on these modifications of alpha-synuclein, but it's still kind of a new area of research, and a lot more research needs to be done in this field. What kind of sets my paper apart is that a really few number of articles discuss these post-translation modifications um, comprehensively and with a variety of modifications in one paper. And some areas of weaknesses in researching this topic is that these modifications have been like studied in vitro, which means like in laboratory conditions using recombinant alpha-synuclein, and it hasn't really been extensively studied in vivo in humans. So some of the findings of so some of the findings of the research may not translate exactly to what is actually happening in humans. So this is some research that could be um taken further and looking at it like what's happening inside humans. And so my results and methodology were that. So I basically just looked at a bunch of different papers analyzing these post-transition modifications, and I took the most like important part of how these modifications affect alpha-synuclein and kind of and talked about it in detail comprehensively in one paper. And so my results showed, so I focused my research on four of the main post-translational modifications of alpha-synuclein, which were a phosphorylation, acetylation, ubiquitination, and truncation. So some of the results I found was that phosphorylation showed changes in the aggregation, localization, and metal binding properties of alpha-synuclein. Acetylation displayed alterations in the structure of alpha-synuclein. Ubiquitination could have effects on alpha-synuclein's aggregative properties, and truncation may play a role in the misfolding of this protein. And so some of key takeaways in this are that phosphorylation and ubiquitination play a major role in alpha-synuclein aggregation, while acetylation could play a protective role against alpha-synuclein aggregation, and this could lead to further therapies. And why this is important is that the aggregation of alpha-synuclein is very like so the aggregation of alpha-synuclein into Lewy bodies is like a hallmark of Parkinson's disease. It's one of the main features of it, and it's like widely associated with the disease. So if we can learn more about how alpha-synuclein aggregates, we can learn a lot about Parkinson's disease. And so just to conclude, research has shown that these modifications of alpha-synuclein are very important in Parkinson's disease. The modifications really do affect alpha-synuclein and its properties, and this leads to changes in the pathogenesis and pathology of PD. And so understanding these modifications will really further our understanding of Parkinson's disease and could even lead to therapies for PD targeting these post-translational modifications. And finally, I would like to talk about my experience with gifted Gabber. First, I would like to thank Dr. Jobin Varkey. I mean, his lectures were really insightful and taught me a lot about neuroscience and these neurodegenerative diseases. And when I started this, I had like no idea what I was going to do and what topic I chose. But after having a one-on-one with Dr. Varkey, I picked out a topic and I like immediately started working on it, and it was like a fun topic that I was able to kind of get started with Dr. Varkey in that one-on-one. And he has really helped me in writing this paper and provided a lot of insight that I used in my paper. I would also like to thank Professor Virgil. He has really helped me develop my writing abilities and write in a scholarly way while and also being like clear in my research and being able to present it in a way that really shows the impact of this research. And I would also like to thank Gifted Gabber and Coach Joe for helping for giving me this opportunity to write this research paper. When this program started, I really like it felt like this was a really daunting task, and I was just terrified of having to write this paper. But after I started and started working on it little by little, I like gained more confidence in writing it, and I also had a lot of fun in writing it. And now that I'm done, I can like look at it proudly. I can look at my completed research paper proudly and reflect on all the stuff that I've learned. And this wouldn't have been possible without Gifted Gabber. So yeah, thank you.
Oh, amazing. You can stop sharing. Thank you for the kind words and for the love that you've given. Thank you so much. It means a lot to us. Almost seems like a crazy idea that, I mean, I started off with, but I have a wonderful team that supports me. And I want to take a moment to, let me just pin myself so I can take a moment to thank Smrita. She works tirelessly. I mean, your idea is good only that much if it's not implemented. So I'm blessed with a wonderful team who's always there. They know that I'm a bit crazy. So there's up and down things that happen, but they've stuck on with me. Smrita is amazing. She's a program coordinator. Saumya, of course, she's my cousin. I've changed her diapers. She has to listen to me. I'm just kidding. But she's always there to run everything in the background. There are a lot of people who are involved in this, and I just want to take a moment to thank all of them, and also specifically Dr. Werke, who's been so approachable, right? That's like the main thing, right? If a teacher is not very approachable or doesn't encourage you, then the learning is not fun at all. So thank you, Professor Werke.